Chapter 6, Plug and Chug, number 22. What is the momentum of an 8 kilogram bowling ball rolling at 2 meters per second? Properly, the question should be, what is the magnitude of the momentum? And or you could just consider the 2 meters per second is in the positive direction. But it is just straight up mass times velocity, so it should be 8 kilograms times 2 meters per second in whatever direction that is. We'll just call it the positive direction. So it'd be 16 kilogram meters per second. Number 24, what impulse occurs when the average force of 10 newtons is exerted on a cart for 2.5 seconds? And again, we can find impulse two different ways. We can find it with the change in momentum or force times time. And in this case, since they gave us force and time, that's the one to use. So the force is 10 newtons and the time is 2.5 seconds. So just multiply 25 Newton seconds or kilogram meters per second, or in class, if you define it, we've been using Descartes, but I'm not defining it here since I'm not writing it down. So Descartes is probably not the right thing. Number 25, what impulse occurs when the same force of 10 newtons acts on the cart for twice the time? Well, if you double the time, you double the impulse. So it will be 50 kilogram meters per second, or Newton seconds. Number 27, how much impulse stops a 50 kilogram carton from sliding at 4 meters per second when it meets a rough surface? So this is the change in momentum. The initial momentum is 50 kilograms times 4 meters per second, which is 200 kilogram meters per second. The final momentum, since you're stopping it, is 0. And so the impulse was the change in momentum, which is 0 minus 200, or negative 200 kilogram meters per second, assuming it was traveling in the positive direction to begin with. Number 28, it's a conservation momentum. You got a 2 kilogram blob of putty moving at 3 meters per second, slamming into a 2 kilogram blob of putty at rest. Now they use putty here because we're dealing with a perfectly inelastic collision, which is the terminology we used in class. So we got the one at rest and the other one coming in and basically sticks to it. So the total initial momentum is 6 kilogram meters per second. That's for the one that's moving, 2 times 3. And the other one at rest, the initial momentum is 0. So therefore, the total initial momentum is 6. 6 plus 0 is 6. And afterwards, they are moving together. The total mass now of the blob is 4 kilograms since they combined. And so 6 is equal to 4 times the initial velocity, final velocity. So the final velocity divided by 4, you get 6 over 4, or 1.5 meters per second, which is what you're trying to show. And that is the plug and chug.